In this video, we will be studying about mathematics.
Students, up till now, you have learned about what are factors, what are prime factors, how to find the prime factors for given numbers using vertical factorization method or the horizontal factorization method. Then you have studied about how to find HCF of the given numbers. Now students, you all know what is LCM. LCM means least common multiple. Least common multiple. Students, this is a very important topic. Please practice this topic because it has got lot of application in your fraction addition and fraction subtraction. Okay, you need, in order to find out LCM of two numbers, or adding two fractions, you need to find out LCM of two numbers. For adding or subtracting two fractions, you are supposed to find out LCM. Okay, so it is a very important topic, or I would say one of the most important topics. Okay, now let us see how you calculated or you found LCM in your previous standard. For example, if you got two numbers, say 8 and 12. Now, in order to find the LCM of these two numbers, what you did was you listed down the table of each number. For example, for 8, you listed down the table of 8. The table of 8 is 8, 16, 24, 32, 40, 48, 56, 64, 72 and 80. Then you listed the table of 12, 12, 24, 36, 48, 60, 72, 84, 96, 108 and 120. Once you have listed the tables, what you did, you found out the common multiples. The common multiples. Now, which are the common multiples over here? You got 24, then we got 48, then we got a 72. So what are the common multiples? 24, 48 and 72. Now we need the least of the common multiples. So what is the LCM over here? LCM is 24. So LCM of 8 and 12 is 24. Now in this standard, what you're going to do is you're going to find out the LCM by factorizing method. We are going to find the LCM by factorizing method. Okay. Now we all know how to factorize two numbers. How to factorize two numbers. Okay. So I'm going to factorize 8 and 12 together. So 8 and 12. How do we factorize 8 and 12 together? We are going to find a number which can divide both 8 and 12. Okay, so the first number, the first prime number, which is 2. The 2 can divide 8 and 12. 2 can divide 8 and 12. So this goes 4, this goes 6. Then 2 again. 2s are 3s are. Now you cannot further divide 2 and 3 with the same number. Why? Because both are prime. Then we stop the factorization. Over here in LCM, what you're going to do is you're going to multiply all the numbers which are on the edges. There are two edges. One is the vertical and one is the horizontal. So on the vertical, I have got this 2 multiplied by 2. And the horizontal, I have got 2 multiplied by 3. That is equals to 24. See, 24 and 24. So From now onwards, we are going to find out LCM by this method. Okay, now let us look into a few more examples. What I'm going to do is I'm going to start solving some sums from your practice set number 13. Okay, so your practice set number 13. I'm going to solve a few sums. So practice set number 13. The first sum. The first sum is 12 and 15. 12 and 15. You have to find the LCM of 12 and 15. So how do you find the LCM of 12 and 15? 12, 15. Again, the first prime or the prime number, the least smallest prime number that can divide both 12 and 15 is 3. So 3. 3 fours are 3 fives are. Now after this we cannot get any other prime number which can divide both 4 and 5. So LCM you have is 3 into 4 into 5. What is 3 into 4 into 5? 3 fours are 12. 12 fives are 16. So LCM of 12 and 15 is 60. Okay, now let us look into sum number 2. The sum number 2 is you have to find LCM of 6, 8 and 10. LCM of 6, 8 and 10. Okay, now let us start finding the LCM of 6, 8 and 10. So I got 6, 8, 10. So the first or the smallest prime number which can divide both all the three digits 6, 8 and 10 is 2. 2 3s are 2 4s are and 2 5s are. After this we cannot get a number which can divide all these three digits. So the LCM will be 2 multiplied by 3 multiplied by 4 multiplied by 5. So what is the answer you get? 2 3s are 6, 6 4s are 24 and 24 5s are is 120. Getting it? I hope you have understood how to find LCM of given numbers. So what you do is you can practice the other examples given in your practice set 13 in order to understand and learn about LCM. Okay, now let us move further. In your exercise number 13, there is one more type of sum. The question number 2, which says find the HCF and LCM of the numbers given below and verify that their product is equal to the product of the given numbers. Now remember students, the product or for any two numbers or any three numbers, four numbers, how many numbers you're finding LCM and HCF. Okay, the product of all these numbers is equal to the product of their LCM and HCF. For example, look at over here. In this example, what is the LCM we found out? 60. Now what is the GCD or HCF we have? HCF. HCF is always from here we take, this is HCF. So HCF is how much? 3. So what is LCM into HCF? LCM into HCF is what? 60 into 3, that is equals to 180. Now what is 12 into 15? 12 into 15 is also 180. See, LCM, the product of LCM and HCF is equals to the product of the numbers. Okay students, now let us move forward and solve sums from your practice set 13, question number 2. You have to find the HCF and LCM of the given two numbers, pair of numbers, and you have to verify the result also. So what I'm going to do is I'm going to solve sum number 3. I'm going to solve the sum number 3. Okay. In sum number 3, you have got 15 and 16. 15 and 16. So 15 and 16. This goes in the table of 3. 3 5s are 20s are. Then this goes in the table of 5. 5 1s are and 5 4s are. Okay, we cannot further divide these numbers with a common prime number. Now, let us see which is what is the HCF. What is the HCF you have? HCF is 3 into 5. 3 multiplied by 5, that is equals to 15. Now let us see what is the LCM. LCM. LCM is what? 3 into 5 into 1 into 4. So 3 into 5 into, you can skip 1 and you can directly write 4. So 3 5s are 15, 4s are 60. Okay. Next, we are going to find the product of HCF and LCM. Product of HCF and LCM. So 15 multiplied by 60. That is equals to 900. That is equals to 900. And product of two numbers. What are the product of the given numbers? Given numbers of 15 and 60 is 900. So this is equals to HCF into LCM. So students, you can notice that the product of the given numbers is equals to the product of HCF and LCM. Now students, I hope you will be able to solve your practice set number 13. So assignment is to solve practice set number 13.